In this video, we're going to talk about a differential equation topics called slope fields. So let's think about the differential equation dy over dx equals 2x. What would some solutions to this equation look like? Well, a solution to a differential equation is really just the antiderivative. So one antiderivative of 2x might be x squared plus 3. Another one might be x squared minus 5. So really all of the solutions have the form x squared plus c. So what a slope field does is a way to graph them, graph all of the solutions to a differential equation on one graph. If you think about x squared plus 3 would look something like this. X squared minus 5 would look something like this. They're basically vertical shifts of each other. But how could I represent every single antiderivative on a single graph? It would be impossible for me to graph every parabola on this graph, but a slope field gives us a way to really represent all of the graphs of the solutions of a differential equation. So let's look at example 1. The first thing you want to do is look at the differential equation given. In this case, it's dy over dx equals x minus 1. So the first thing you want to notice is the variable in the equation. This equation only has a x in it, so I'm just going to set myself up a table, and I need an x value and I need the derivative value, or the differential equation value. And so if I look at this graph, x goes from negative 4 to positive 5. So I'm going to fill in my table, negative 4 to positive 5. And then I'm going to plug all of these numbers into the differential equation to get the slope. So for the first one, I'm taking negative 4 and I'm plugging it in for x. Negative 4 minus 1 is negative 5. And I'm just going to do that all the way down the table. Negative 3 minus 1 is minus 4. Negative 2 minus 1 is negative 3. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1, and so on and so on. So 1 minus 1 becomes 0, 2 minus 1 is 1, 3 minus 1 is 2, and then we get 3, and then we get 4. So we're not going to graph these as traditional points. What a slope field does is it graphs little lines at every point on the graph paper. And notice we gave you dot paper. You'll always graph a slope field on dot paper. So you go to where x equals negative 4. That's this whole column right here. All of these points represent where x is equal to negative 4. So what we want to do is just go to one of the points where x equals negative 4, and we want to draw a little line that has a slope of the differential equation. So at negative 4, the slope is negative 5. So let's just start at negative 4, 0. I want to draw a little line through that point with a slope of negative 5. So if you think about slope, that's a rise over run, that would mean if I had a slope of negative 5, the next point would be down 5, 1, 2, 3, 4, 5, and over 1. So the next point of this line, if I connected these 2 points right here, would be down here. I can make a line like this. But when I'm graphing slope fields, I only want a little tiny piece of that line. So I'm going to erase everything and just leave a little tiny piece of the line. And then basically what happens, everywhere that x is negative 4, I'm going to have that same slope of negative 5. So all the way up and down the column, I can put in lines with parallel slope to that line, because they all have slopes of negative 5. And you're just eyeballing it. It doesn't have to be perfect. They should all look pretty similar. So then I'm going to do the same thing where x is negative 3. So I'm just going to start here at negative 3, 0. So if I have a slope of negative 4, I'm going to come down 4 points, 4 and over 1 to get my next point. So I want to think about connecting these 2 points with a line. And again, you only want a little piece of it. So a slope of negative 4 should be slightly less steep than a slope of negative 5, and I don't think I did a very good job with that, so I'm just going to redraw this one. It should look slightly less steep than negative 5. It's really hard when they start getting steeper and steeper to really show a difference. There, I think that's good enough. So then I want to just, again, go up and down the column and put parallel lines to that line. So go up and down the column, put parallel lines to that slope. So all of these have a slope of negative 4, which again should look slightly less steep than our slope of negative 5. Okay, so then at negative 2, we're going to have a slope of negative 3, so that's down 3 points over 1. So I think about connecting those 2 points with a slope. And then I do the same thing up and down the column. And then I go to negative 2, or negative 1, sorry. Negative 1 has a slope of negative 2, so I think of going down 2 points and over 1, so right here. So my slope's going to be something like this, and then I can go up and down the column again, and all of these have a slope of negative 2. And you can see how as I go across horizontally, the slopes get less steep, which is exactly what should be happening. And then at 0, I have a slope of negative 1, so I'm just going to slant it down, negative 1, down 1 over 1. So it just looks something like this, kind of cutting the grid in half. Everywhere that x is 0, I get slopes of negative 1. And then at 1, I get slopes of 0. So a slope of 0 is a horizontal line. So everywhere x is 1, I'm going to put a horizontal line. And now I'm switching to positive 1, so now all of my slopes should be slanted upwards, so a positive 1 slope would look something like this. And then a positive 2 slope would be a little bit more steep. Again, you can think about if you're going from here, you're going to go up 2 points and over 1 and connect with a line. So it looks something like this. And the whole column should look parallel. And then I have a slope of 3. That's going to look even steeper. And eventually, if you get really high slopes like 9, 10, your lines are pretty much vertical, and that's just the nature of what it does when you're graphing in such a steep interval. And then I have a slope of 4. So these are going to look a lot more steep than anything else. So if you look at this graph, it might look kind of crazy at first, but what this is actually showing us is the shape of all the solutions to this differential equation x minus 1. Well, what's the antiderivative to x minus 1? It would be x squared over 2 minus x plus c. That's a parabola. Can you see the parabola shape in the graph? You've got the vertex right there at x equals 1. So if I could draw in, maybe I have a parabola like this, right? That would be one solution. And you could just keep drawing in parabolas all the way up and down the slope field. So you should be able to see the antiderivative shape in the slope field. In the next example, you'll notice we only have y in the equation. So this time when I set up my table, I'm only going to use y and dy dx. So this time, let's see, the y's go from negative 4 to positive 5, just like the x's. So I'm going to do the same thing, list them out. And then I'm going to fill in all the slopes. Well, the equation's just negative y, so I'm just multiplying all these numbers by negative 1. Basically just flipping the sign of everything. And then I'm going to go about this the same way, but because I'm dealing with y's, all the y's are the same in a row. This is the place where all the y's are negative 4. So instead of moving up and down columns, I'm going to be moving left and right in horizontally. All right, so let's start with y equals negative 4. So I'm just going to start on the y-axis. I have a slope of positive 4. So again, think of going up 4 dots, 1, 2, 3, 4, and over 1. So I'm thinking about connecting these 2 points with a straight line. So it would look something like this. And then now, instead of moving vertically up the column, I've got to move horizontally on the row because this is where y is equal to negative 4. All of these points. So all of these are going to have the same slope. So the lines should all look parallel. And then I'm going to go to negative 3, so I should have a slope of 3. So think about going up 3 over 1, so I can use that same point right there. So this should be a little less steep. And then I can move across the row horizontally because all of these points are where y equals negative 3. Okay, so then at negative 2, I have a slope of negative 2, which would look something like this. And again, as I go up, these should be getting less steep. A slope of negative 2 is less steep than a slope of negative 3. Okay, so at negative 1, I should have a slope of 1, which is, again, less steep than everything else. So as I move horizontally, everything should look the same. At 0, I have a slope of 0, so this should be my horizontals. All of these on the x-axis get horizontals lines. Then at 1, we switch to a slope of negative 1, so we're going to slant it down all the way across. At 2, we have a slope of negative 2, so it should start to look steeper again. Negative 2, excuse me. Looks steeper again. And then we get to negative 3, so again, that should look steeper than negative 2. And then we get to negative 4, so it's starting to get really steep. And the negative 5 is going to be the steepest. And it might almost look vertical, depending on how you've been doing these, and that's okay. Eventually, the steeper you get, the more vertical you get. So, can you see the solution curve in this example? What's the antiderivative to negative y? So if my derivative equals negative y, I'm basically saying that the derivative is the negative value of this original function. Y represents the original function. So if you think about that, who is its own derivative? It has to be e to the x. In this case, it would be e to the negative x because the second one is negative. So you can see right in the graph the shape of e to the negative x. That's here. Or you could also have a point down here. If you pick a point below the x-axis, you'll get this shape, which is negative e to the negative x, which is also possible. So those are all the solutions to y equals negative y. In example 3, we have a differential equation that involves x and y. We've got x minus y. So we have to think about picking points, not just x values or y values now. So we need a point, and then we need the slope. So just pick yourself some points scattered around the graph. We're not going to list them all out. That would be kind of tedious. But we're going to do enough that we can hopefully figure out a pattern. So just try and pick your points all around the graph. Some positive, some negative. And hopefully, like I said, some kind of pattern will usually emerge. So let's just start with these and we'll see where we go. So the equation is x minus y. So I'm doing negative 4 minus 4. So that would give me a negative 8. That's going to be a pretty steep negative slope. Probably going to look pretty much vertical. Negative 4 minus negative 3. So that's actually a plus 3. So that would give me a slope of negative 1. Negative 3 minus 2 would give me negative 5. Negative 3 minus negative 3. So we have negative 3 plus 3 would give us 0. Negative 2 minus 1 would give us negative 3. Negative 2 minus negative 4, so that's really negative 2 plus 4, so that's a slope of 2. Negative 1 minus 0 is obviously just negative 1. And negative 1 minus 1 is negative 2. So let's fill in what we've got so far. So negative 4, 4. 1, 2, 3, 4 would be here, and that's a slope of negative 8. 1, 2, 3, 4, 5, 6, 7, 8 would be here. So I have to slant that really far down, so that's going to be very, very steep. Negative 4, negative 3 was right here, and that's a slope of negative 1. Okay. Negative 3, 2. Slope of negative 5, and that's pretty steep too. 1, 2, 3, 4, 5. So here's my fifth point here. So if I think about connecting those 2 points, I get a line about that steep. Negative 3, negative 3 is a slope of 0. So remember, a slope of 0 is horizontal. Can you think of any other places where you would get a slope of 0? Since it's x minus y, if I did like 1, 1, 1 minus 1 would be 0. Obviously, 0 minus 0 would be 0. 2 minus 2 would be 0. 3 minus 3 would be 0. 4 minus 4 would be 0. 5 minus 5 would be 0. And so you can see you have a diagonal pattern here on the zeros at least. So negative 1 minus negative 1, 0. Negative 2 minus negative 2 would be 0. And negative 4 minus negative 4 would be 0. So that's what I mean about not having to do every point. Sometimes you can figure out a pattern, and that helps you fill in some of the points, which is a lot faster than literally writing out every point. Okay, so where did we stop? Negative 2, 1. Negative 2, 1 would be here, and that has a slope of negative 3. So think about going slanting down 3 points, something like this. Negative 2, 4, or negative 4, sorry, 1, 2, 3, 4 would be here, and we have a slope of positive 2. And negative 1, 0 has a slope of negative 1. And negative 1, 1 has a slope of negative 2. So maybe we don't have enough for a pattern yet, but we can just start thinking about doing it in our heads. So if I'm just going to go back to the negative 4 column, negative 4, 0, negative 4 minus 0 is just negative 4, so I have a slope of negative 4. Negative 4 minus 1 would be negative 5, so it's going to be a little more steep. Negative 4 minus 2 would be negative 6, so more steep. So this would be negative 7. We already did negative 8, and this would be negative 9 up here, which is going to be, almost looks vertical, it's so steep. And so then when I go down to the negatives, I'm actually adding the y value because the negatives cancel each other out. So this becomes a negative 4 plus 1, so that gives me negative 3. So now I'm going to get less steep. This becomes a negative 4 plus 2, so that's negative 2. We already did the negative 1, so you can see they're just going down 1 as you go down the column, which makes sense because it's subtraction. Negative 3, 0 is just negative 3. Negative 3 minus 1 would give me negative 4. This was negative 5, so this would be negative 6, negative 7, negative 8. So now as we go down, it gets less steep. So if this was negative 3, this one will be, the one here will be negative 2. And then negative 1, 0, and then it flips to a positive because now we're at negative 3, comma, negative 4. Well, negative 3 minus negative 4 is positive 1. So as we go down the column, the slopes go up by 1. So here we have negative 2, slope of negative 2. This was negative 3, so this will be negative 4, negative 5, negative 6, negative 7. And so as we go down, this would be negative 1, 0, and then it switches to positive 1. See a pattern yet? It's starting to emerge, I believe. Here we had a slope of negative 1. This was a slope of negative 2, so then we have negative 3, negative 4, negative 5, negative 6. This was 0, so then it goes 1, 2, and 3. So you see a pattern right here maybe, right on this diagonal. All of these seem to be a slope of 1. So I think we can fill these in. Slope of 1. We already did the zeros. Right above the zeros, we get a slope of negative 1. So kind of, that goes this way. Slopes of negative 1. So we can fill those in. So then this down below the positive 1 would be positive 2. So these are all positive 2. And then it would be positive 3. And then it would be positive 4. And then it starts looking real steep because it's positive 5, positive 6, positive 7, 8, and 9. By the time you get to those, they're pretty much vertical because we just can't scale it any steeper than that. So then we did the negative 1. So on the next diagonal up would be negative 2. And then the next diagonal up would be negative 3. And then negative 4. And then negative 5. So we get the whole graph there, and if you look, we actually have what's called a slant asymptote in it. So the curves are going to do something like this. Maybe if I had a point here, it would come down. It would have to flatten out because of that 0, but then it can't cross this line, so it's going to look something like this. So that's what one of the solutions would look like. Now the last one we're going to do is an actual AP question, but before we get to that, the reason I have the calculators up is because you can graph slope fields in the calculator. So if you open up a graph, you're going to have to change the settings. So go to Menu, Graph Entry, and number 7 at the bottom it says Differential Equations. So you can graph a differential equation in the calculator, and I want you to know how. However, most of the time on the exam, they do show up in the non-calculator. So you type it in the way it looks. However, when you have to type in a y, you have to type in a y and then the number of what the y position that you're doing. So this is y1, so I'm going to type in a y1. So I have to type in x minus y1. If I had been typing in the y2 slot, I would say x minus y2. So if you hit enter, you can see that that slope field matches what we've been doing. And then also, if you bring the tab back up, go back up to y1, if you notice below, there is a spot to add a point. So maybe I want to go through 0, 1. If I add a point in, it's going to add in the solution curve. It's going to show you what it looks like. So the calculator is very handy, and I don't mind if you use the calculator to check, but again, keep in mind you will not most likely have the calculator in the slope field section of the exam. It's usually in the non-calculator. Okay, so this is what slope fields will generally look like on the exam. They'll give you some kind of equation, differential equation, that generally involves x and y. They'll provide the graph, the dotted graph paper, and generally they give you about 12 points. And in this one, they do ask you to draw in a solution curve through the point 0, negative 1. So if you think about it, we have x plus 1 over y, and then we want the, sorry, just want to write that as x comma y. So we're going to have all these points, and we want to figure out the differential equation. So we're just going to use the points that are listed on the graph paper. So I have a point at negative 1, 1. Negative 1, 2, negative 1, negative 1, and negative 1, negative 2. So let's just start with those. So we're going to plug those into the differential equation. So on the top, I would get negative 1 plus 1, which is 0, over 1. So that's just a slope of 0. Negative 1, again, plus 1, that's a slope of 0 over 2. So all of these are going to be a slope of 0. Okay, so then I'm going to do the zeros. I have 0, 1, 0, 2, 0, negative 1, and 0, negative 2. Now, do not add your own points to these. Only use the points that they give you. So 0 plus 1 on the top, I'm just going to have 1 over 1, 0 plus 1 over 2, 0 plus 1 over negative 1, and 0 plus 1 over negative 2. So that gives me 1, a half, negative 1, and negative a half. So at 0, 1, I have a slope of 1. 0, 2, I have a slope of a half. So that should be less steep. Slope of a half should be less steep than a slope of 1. Then I have a slope of negative 1 and a slope of negative a half. Okay, and then I have to do the ones. 1, 1, 1, 2, 1, negative 1, and 1, negative 2. So 1 plus 1 is 2, so I get 2 over 1. 1 plus 1. So I'm going to get 2 on the denominator of all of these. And on the bottom, I get the y values. So it gives me 1, negative 2, and negative 1. So at 1, 1, I have a slope of 2. And then I have a slope of 1. At 1, negative 1, I have a slope of negative 2. And then I have a slope of negative 1. And then the last thing it wants me to do is draw the solution curve through 0, negative 1. So that's here. So you got to just follow the shape of the lines. It's going to have to come, this part's going to have to slant down. And then this part's going to have to flatten. And then you really don't know what happens on the other side of that because you don't have the rest of the slope field. So you just have to stop there.